Okay, hey everybody. We're going to do the day 11 notes today talking about linear inequality application problems. So we have a procedure for application word problems in general that we talked about yesterday. We're going to read the problem carefully, highlighting important key words and information. Then determine if the word problem represents, in this case, a linear inequality, meaning we'll use the less than, less than or equal to, greater than or equal to signs with multiple solutions, meaning we'll have shading required. Then we'll determine the correct axes for the graphing depending on the domain. We're going to use an L-shaped whenever we have no negatives allowed in the domain, and then a T-shaped if the x values can be negative. So let's look at a question together. Okay, so the first problem says we have Olivia going to a Halloween party and needs to bring an appetizer. She only has $50 to spend. She decides to make a cheese and grape tray. 1 pound of grapes costs $3 and cheese costs $5 per pound. We're going to write an inequality. So even if we weren't sure, the words here tell us that I need to use an inequality. Now, how did I know that we needed an inequality? When I look back, she has $50 to spend. She could spend less than the $50, or she could spend all $50. So that's what tells me that it's going to be an inequality. And it's going to represent the cheese and grapes that she can take in relation to the amount of money she has to spend. If I look at my axes right here, I can see that I have the number of pounds of cheese on the y-axis and then the number of pounds of grapes on the x-axis. So that tells me my let statements. I could write let x equal the pounds of grapes and let y equal the pounds of cheese, but I see them on my x and y axis, so I just use it from there. I'll write it in case you want to have the let statements also. So now using that information, I can write an inequality starting with, since grapes are $3 a pound, I start with the 3x, plus she's buying cheese for $5 a pound, so 5y, and that's how much we're going to spend. It can be less than or equal to the $50, because we cannot spend more than the $50. Okay, so now we have an inequality, and we can move to getting it into y by itself, so I can graph it on the grid below. So in order to graph this, we have to first get this into the y on one side and the x, so we have it in mx plus b form with an inequality instead of the equal, obviously. So the first thing I would do is subtract the 3x from both sides. The negative 3x and the 50 are not like terms, so they cannot be put together, so I just put it in negative 3x plus 50, and then we need to divide all the terms by 5, so the y, the negative 3x, and the 50. And when we do that, we get y is less than or equal to negative 3 over 5x plus 10. Now we have this y by itself, and I can go ahead and put this in my calculator to get a table of values. So in y equals, you plug in the negative 3 over 5x plus 10, and then hit second graph to look at your table of values. Hopefully you have the same tables that I wrote on my board here. So 0 is with 10, 5, 7, 10, 4, and 15, 1. Now that I have all these points, I can go ahead and graph them on my grid. So you may need to pause the video to make sure that you have enough time to graph. I just put the 0 up 10 and then went over to 5 up to 7, 10 up to 4, and then 15 up to 1. Now that I have all my points plotted, I need to connect with a line, and since it's less than or equal to, that tells me I'm going to need a solid line to connect them. And you'll notice that I have no arrows on my graph, so we cannot go into the negative, so they have to stop over here. I can't have negative pounds of cheese, so I can't go down this way. I can't have negative pounds of grapes, so I cannot go this way. So it needs to stop at these two places. This one isn't a perfect point here, that's why it wasn't on my table. We can see that it's in between here. Now I need to figure out which way to shade. And remember that you can always use a test point to try to figure that out, or you can think to yourself, which way do I think it would shade? And then use the test point to check, like we did in class. So, since its y is less than or equal to, I think it would make sense to shade below my graph. So I'll go ahead and try that by using test point 0, 0, which according to that would mean that 0, 0 is a solution. So remember, we always go back to the original for our test point. So off to the side over here, I just wrote TP for test point 0, 0. Then, using the original, the 3x plus 5y is less than or equal to 50, I plugged in a 0 for my x using that test point, and a 0 for the y from my test point. 3 times 0 is 0, plus 5 times 0, 5 times 0 is 0, 0 plus 0 is 0. So this equates to 0 is less than or equal to 50, and you can also put that right into your calculator. That is a true statement, so that tells me that 0, 0 should be in my solution region, which when we talked about shading below, it is in the solution region. So then I shaded below, I put the S to show that that's where all the solutions are, and then put my label on the inequality graph. So that's it for this one. Now I could identify solutions for the last part of the question, where it says to state one possible amount of cheese and grapes that she could buy. So I can choose any point on the line, since this one is less than or equal to, or in the solution region. So you just need to pick a point anywhere in here. So for example, I'll choose one, like I said, it can be any, so there are multiple options. If you wanted to choose a different one, that would be fine. I'll choose one close to the S over here. I'm going to do 3, so 4 pounds of grapes and 3 pounds of cheese. So I just wrote that out to show that that's my answer. 4 pounds of grapes and 3 pounds of cheese is a possible solution. Okay, on to the next question. The next question says, Sarah is selling bracelets and earrings to make money for a summer vacation. The bracelets cost $2 and the earrings cost $3. She needs to make more than $600 to pay for her vacation. Write a function to represent the number of bracelets and earrings Sarah sells in relation to the amount of money she needs to make. Well, this time they didn't tell me that I needed to write an inequality. So I had to use the words in there to identify that I needed an inequality. Since she needs to make more than, that means that she could make exactly 600 or she can make more than the 600. So this is what tells me I need an inequality. And we also don't have anything showing on the x and the y, so we need to identify what we're going to use to represent the x and the y. Okay, so you can see here I wrote my let statements. Let x equal the number of bracelets. I already know the cost. I don't know how many. And then let y equal the number of earrings. Then I'm ready to write my inequality showing that that Sarah is selling them and she needs to make more than $60. So if she sells the bracelets at $2, that's 2 times the number of bracelets she sells, x, plus the $3 for the earrings, so 3y, $3 per earring pair. And then it's just, she has to make more than, so greater than the $600, not equal to, because they said she has to make more than $600 to pay for her vacation. So that's my inequality. Now I'm ready to take this and move down to graph it on the grid below. So I just rewrote my inequality down here, and I have we need to use the grid to sketch a graph of the function and then state one possible combination. So just don't forget that that's part of our instructions. After we have solved it, we need to state a possible combination. So that's part of our answer then. So I'm going to start by labeling my x and the y-axis so I know what they're representing. So now I just wrote on the x-axis the number of bracelets and on the y the number of earrings. Now, if you remember, when we first talked about graphing, we always had getting y by itself so that then we have the slope and the y-intercept, and we can use that to graph the situation. Now, we also had another way that we talked about where we found the x-intercept and the y-intercept and used those 2 points to plot the entire situation. It doesn't always work, but it works sometimes, and this is a case where it would. So I'm going to show you how to use that in case you want to use the x and y-intercept. And it's not too difficult to find because when we think about if we're looking for the y-intercept, that means that we're on the y-axis. So if we're on the y-axis, I can't move left or right at all, so the x value would be 0. So I just wrote that down. For the y-intercept, the x would be 0. So then in my inequality, I'm going to plug in the 0 in place of the x. And remember I talked about you might realize that that means that that's going to be gone, but I'm just going to write it in case you need to see it. But in the next line, the 2 times 0 is just 0. So I have 3y is greater than 600. And then I just, to solve for y, divide by the 3. And when I divide 600 divided by 3, I end up with 200. So that means that even though I wrote it in the inequality here, it really means that the y value for the intercept is equal to 200. So this tells me that the point, even though the inequality tells me that that point's not included, but the point is 0, comma 200, x, comma y. Now I'm going to do the same thing for my x-intercept. I have my y-intercept, now I need the x-intercept. So similar to what we did before, for the x-intercept, that means that the y value is going to be equal to 0. So filling in that same thing, the x-intercept, the y value equals 0. So now I plugged in the 3 times 0 in for the y value to equal 0. So I'm left with 2x on the left side here is greater than 600. And then to get x by itself, we divide by 2. So again, technically I would end up with an x is greater than here, but I'm really solving for the intercept, so I'm going to change that to the 300, that it equals the 300. Like I said, I can leave these as we just solved for them. It's going to be greater than, but the whole point of that was to find what the y values and the x value was for the intercept. So then now I know that the intercept for this point would be 300 as my x and then 0 for the y. So now I have these 2 points that I can plot on my graph. So now this also helps me see what I need to count by. I need to show on my y, the biggest y I have is 200 and the biggest x I have is 300. So that tells me I need to count by something bigger than what I might have normally counted by, since I need to get all the way up to 300 and the 200. So since I need to get up to an x value of 300, that means that I can't count by tens because that would only get to 200, but that would work for the y since the biggest y is 200. So that means I'd have to count by something, either 20, if you wanted to do 20, that would work, or you could do 25. Either one really works as long as I stretch it out a little further. Remember, we're always trying to adjust the scale so that we can show a good amount of the graph. So I chose to count by 20s because that would show all the way up to 400. Then on the y's, I'm going to do, like I said, I'm going to count by 10 since I only need to show up to 200. So I made every block worth 10, and I just showed, the 50, the 100, 150, and 200. Now that I have my x and my y labeled with my numbers, I can go ahead and plot my x and y intercept with the way that we did this. So I'm going to go to 0 up to 200, and I'm going to put a dot, and then I'm going to go to 300, 0. And now I have my 2 points. Since we're going to use a straight edge, I can connect them with a dotted line. So you can see here I have filled in the dotted line. Yours will probably look a little nicer. Obviously, it's a little more difficult to do on the touchscreen Chromebook without having other things pick up on it, but a dotted line shown there. And then now you can, again, either do the test point to see, or you can think to yourself, so since it's greater than, y has to be greater than, I can see the y on the other side. I'm going to think that it's above, but I'm going to use a test point to make sure. So down at the bottom, I just wrote test point 0, 0, and then I put in the 0 in the inequality that I wrote. So I had the 2x plus 3y is greater than 600, so I just wrote that as 2, plugged in the 0 for x, 2 times 0 plus 3 times 0 for the y is greater than 600. 2 times 0 is 0, 3 times 0 is 0, 0 plus 0 is 0, or remember, you can put that all in your calculator, and then I end up with 0 is greater than 600, and 0 is not greater than 600, so I'm going to write false next to this, and because that's false, that tells me that my shading should go above, which is where I had initially thought it would go. So you can use the test point, or you can do where you think that it would go, but I think that it's always a good idea to use the test point just to check to be sure that you shaded the right way. And then I'm shading all above my line. Remember that you don't want to go over the line, up to the line, and showing that all of my solutions are up here. And I'm going to put an S to show you. That's where all of my solutions are. And then you can always put the label on the inequality. Like I said, it's the most important for when you have systems of inequalities and equations, but it's always a good idea to label. And then it also asked us to identify a solution. Now this time we cannot use points that are on the line. The solutions have to be in my shaded region. So a point on the line would not be included. So I'm going to put a solution for you. So the solution that I chose, and remember you can choose a different one, but it needs to be in the solution region. I chose 200 for the bracelets, and then I went up to this point here, which was 120, 10, 20, since I counted by tens, 120 earrings. And you can always check that in your inequality also. Just a reminder, I use the x-intercept and the y-intercept for this one. You could also have taken this 2x plus 3y is greater than 600 and got it into y equals form instead, and then gone to second graph, well, put it in y equals, and then second graph to look at the table, write down a table of values, and plot from that. Either way is fine. The part C here says, explain what point 24, 184 represents in this model, and would Sarah be able to pay for her vacation? Explain. Well, the first thing that I need to do is identify where that point is. So 24, 184. I counted by 20s on the X, so 20 and then a little bit more. And then up to 184 would be 150, 60, 70, 80. It'd be right around here. So I think that this is hard to see since the scale doesn't show exactly. So we would either need to go to the table and look at it that way, or sub in my X and my Y to find out if it makes it true or not. So first let's explain what the point means. The 24 is the X, that means that's the number of bracelets. The 184 is a Y, that means it's the number of earrings. So this point means selling 24 bracelets and 184 earrings. Now I need to find out if that's enough to pay for the vacation. I'm going to plug those values in for the X and the Y. So I wrote that down, 2 times the 24 plus 3 times 184. Then I put that in my calculator and I ended up with 600. So since 600 is not greater than 600, it's equal to, that means that she would not be able to pay for her vacation. So I wrote that out as Sarah would not be able to pay for the vacation because those amounts would give her $600 and she needs more than 600. So remember, points on dotted lines are not included. Okay, that's it for today's lesson. Have a great day. We'll see you tomorrow.